Okay, so today we're going to be talking about a very important math topic in algebra and number theory, and we're going to be talking about modular arithmetic. And modular arithmetic is especially important in like number theory. It's basically like the study of remainders and how remainders work. So basically, a modular arithmetic can allow us to relate numbers that like have the same remainder when divided by another number. So what that means is like the general like equation kind of a modular arithmetic is if I write something like A is congruent to B mod M. So this you can kind of think about as like it's similar to a normal mathematical equation, right? Normally we could say something like, 5 is equal to 5. Like this is a normal math equation without any like modular arithmetic stuff. But this top equation here, kind of A is congruent to B mod M. This is kind of like a modular equation here. And this equation, we don't call it an equation. In modular arithmetic, we kind of call it a congruence. Because A and B don't actually have to be equal in order for this statement to be true. So let's break this statement down just to like help us better understand what this like means basically. So first of all, A and B are just kind of like random numbers, right? They can just be like any real numbers. So those are not very interesting. The first interesting thing is like this symbol here. It's like the symbol with like 3 lines. So normally this is kind of like the equal sign in a normal math equation, but instead of 2 lines, like an equal sign, we instead this time have 3 lines. And this is kind of like a congruence statement. So what this means is like, I read it as A is congruent to B mod M. And we'll talk about what does congruent mean. We'll talk about that like soon. And now let's talk about this last part here, mod M. So mod M is just short for like modulo M. Mod is just like an abbreviation for modulo, and mod M just means like you're going to take the remainders when you're going to look at A and B, and you're going to take the remainders when A and B are divided by M. So what this like statement means is if A is congruent to B mod M, then that means that A and B leave the same remainder when divided by M. So for example, I can say like 9 is congruent to 2 mod 7. Because like 9, when you take 9 and you divide it by 7, you get a remainder of 2. When you take 2 and you divide it by 7, you also get a remainder of 2. So that tells us that 9 is congruent to 2 mod 7. So we can kind of construct these modular equations now, like these congruent statements. Another example would be like something like if I had 100 is congruent to 34 mod 11, for example, because if I take 100 and I divide it by 11, then I get a remainder of 1. And then if I take 34 and I divide it by 11, I also get a remainder of 1. So they leave the same remainder, which allows us to make this establishment 100 is congruent to 34 mod 11. And in fact, another useful property of like these congruence statements, these modular equations here, is that we can actually extend the definition of a remainder to like negative numbers as well. So notice here, 100 leaves a remainder of 1 when divided by 11, and 34 also leaves a remainder of 1 when divided by 11. So if you were to like subtract 134, you would get like 66. And an important thing to notice is that 66 is actually a multiple of 11. So it turns out we can generalize our definition of modular arithmetic if we had the statement A is congruent to B mod M. So this is the thing we started out in the beginning. We originally defined this as meaning that A and B leave the same remainder when divided by M. You can also think of it as like subtracting B on both sides to say A minus B is congruent to 0 mod M. So you can also think of this original definition here as A minus B is divisible by M. And the reason thinking about it that way might be better, is because now you can kind of extend it to like negative numbers. So like, for example, you can say like 7 is congruent to -2 mod 9. You can kind of think of this as, because if you were to subtract both sides, if you were to do 7 minus -2, you would get 9, and 9 is divisible by 9, which is why this like statement is like correct. So you can kind of think of as like -2 kind of like leaves a remainder of 7 when divided by 9. You can kind of think about like that way.